Hey YouTubers, thanks for joining me here at Random Chemistry. This video I'm going to give you an introduction to determining oxidation numbers. Alright, so there are some general rules that you can follow when you're trying to determine oxidation numbers. The first rule is that an atom in its elemental form has an oxidation number of 0. So, for example, the atom sodium has an oxidation number of 0. O2 gas, so even though this is a formula, it's still this simple atom, or this one atom of oxygen, so the oxidation number is 0. Sulfur gas, even though there's 8 of them, it's still an oxidation number of 0. As long as it's not an ion, the oxidation number will be 0. Rule number 2. An atom in a monoatomic ion has an oxidation number equal to the charge of the ion. So for example, if we had a sodium ion, it's only got 1 plus, so its oxidation number would be plus 1. It would be 1. And if we had magnesium, its oxidation number, if it has a charge of plus 2, then its oxidation number would be plus 2. Rule number 3. In compounds, oxygen will have an oxidation number of -2, and hydrogen will have an oxidation number of -1. Now there are some exceptions to this rule. That's why these are general rules to follow. So the exception is for oxygen and hydrogen. So -1 for oxygen and peroxides, and -1 for hydrogen and hydrides. If you're in a basic chemistry class, you probably won't have to worry about these two exceptions. You're probably going to deal with simple formulas where you'll be using oxidation numbers of -2 for oxygen and -1 for hydrogen. Fourth rule. The sum of the oxidation numbers of the atoms in a polyatomic ion equals the charge of the ion. So here we'll look at an example. Cr2O7 -2. Okay, so here's a polyatomic ion, and it has a charge of -2. So according to this rule, the oxidation numbers for each of these atoms are going to add up to equal -2. Now that we've covered the 4 general rules, we're going to practice. We're going to determine the oxidation number for each atom in this formula, SO2. The first thing I do when I'm trying to determine oxidation numbers is to draw boxes over each element. So this is going to hold the oxidation number for sulfur, and this will hold the oxidation number for O2. And if you remember, according to Rule 4, if you add up the oxidation numbers, they should equal its charge. So this formula has no charge, so that means when I add them together, it's going to equal 0. So according to rule number 3, oxygen typically has an oxidation number of -2. But if you look, I have 2 oxygens. So that means I need to multiply this -2 by 2. So 2 times -2 is -4. To go from -4 to 0, I need to add 4. This is algebra. So that means sulfur is going to have a charge of plus 4. Let's do another example. So we're going to do the same thing. We're going to draw boxes over our atoms. And if you look, this is a polyatomic ion, and it has a negative charge. So that means that these oxidation numbers are going to add up to equal -2. And now we follow our rules. Oxygen typically has a negative charge, or a negative oxidation number of -2. And there's 7 of them. So 7 times -2 is -14. and we're basically doing our math. It's going to be -2. So -14, to get to -2, I would need 12, and 12 divided by 2 is 6. So that means this has an oxidation of +6. So 2 times 6 is 12. 12 plus a -14 is 2. So these are our oxidation numbers. I know it's kind of tricky because it involves algebra, and who likes algebra? Alright, YouTubers, thank you so much for joining me during this video with random chemistry. Please comment, like, subscribe. I really want to hear from you. If there's any material that you specifically want me to cover, if you have any questions, please leave me a comment. Thank you again for joining me, and we'll see you next time on Random Chemistry.